Welcome to Section 1-5, Square Roots and Real Numbers. Today's lesson target is I can evaluate expressions containing square roots. Please copy that down onto your notes. We'll start with two definitions first. Definition of a square root is a number which produces a specified quantity when multiplied by itself. And a perfect square is a number whose positive square root is a whole number. For instance, if I think about the number, if I do 3 squared, which is really 3 times 3, that gets me 9. 9 is the perfect square. If I do 4 squared, which is really 4 times 4, that gets me 16. 16 is the perfect square. So what we're going to do today is we're going to practice with our calculator and look at the first 10 square numbers and their square roots. So down here, we see numbers, integer bases of 1, 2, up through 10. And what we're going to do is we're going to find their perfect square. This is where we can use a calculator. And I will show you how, on the calculator, what we'll do is we'll want to hit the number, the value, the base, and then with the square, either the caret or that exponent of 2 on the x, and then if you hit the caret, we'll hit 2 for the exponent, and then hit enter, and we should get our perfect square. So 1 squared is, of course, 1. 2 squared in the calculator, you could do 2 to the second power is 4, so on and so forth. So please go ahead, hit pause, and then come back and compare your answers with mine. All right, hopefully you have these numbers written down in this column. And these, again, are the perfect squares. Now, when we talk about positive square roots, well, this means that if I take the square root of one of my perfect squares, I should actually get what my base is, the positive square root. So the positive square root of 1 is 1. Again, you're looking for the square root symbol on the calculator, plugging in the perfect square, which for this case will be 4, hitting enter, and you should get 2. Same thing, square root of 9 should get you 3. Go ahead, hit pause, complete this column for the positive square roots, and see if your numbers compare to mine. All right, we should have the following values for the positive square roots. All right, now the negative square root is we can think the opposite of, or it's really the negative square root, so negative 1 times whatever that square root is. So the opposite of the square root of 1, well, I know what the square root of 1 is, it's 1, and the opposite is just negative 1. The opposite of the square root of 4 is really negative 2. The opposite of the square root of 9 is negative 3. Again, hit pause, go ahead, use your calculator, and come back with the rest of the column. Hopefully you had some time to do that and you get the following. All right. Now, in your calculator, I'd like you to plug in the square root of a negative number. So, for instance, if you have the square root of negative 6 in the calculator, do that, and you should get some sort of message. Maybe your message says error, domain error, or syntax error, something. Well, if we think about it, we can never take the square root of a negative number. Because remember, these, for up through what we've been talking about right now, are perfect squares. So when I think about two numbers that have to multiply to get to that, if I think of my multiplication rules with negatives and positives, if I do, let's say, 6 squared is 36. And this means 6 times 6. Well, I can never get a negative number because if I do negative 6 times negative 6, I also get a positive 36. So my multiplication rules I learned earlier this chapter says that if I do a positive times a positive, I get a positive, and a negative times a negative, I get a positive. There's no instance where I could take the square root of a negative number and get two of the exact same answers, right? Or two of the exact same numbers. So I can't take the square root of, let's say, 36 and get it was 6 times negative 6. No, you can't do that because these numbers have to be the exact same. So you can never take the square root of a negative number. So I want you to star that and write it. Cannot take square root of a negative number. The last thing is estimating square roots. So we've been working with perfect squares, which means that when we take the square root, we get integers. Okay? Now, if I were to take the square root of 42, which would of course look like this, in the calculator, I would estimate it, and I would get a decimal estimate. And I'm going to use squiggly equal symbols to say that's an estimated value of, let's say, 6.48. Well, what we're going to do is be able to put that on a number line. So if I think about the square root of 42, and I know that it's the decimal estimate of 6.48, it's really between the two numbers of 6 and 7. Well, when I talk about square roots, if I want to see just square root values on my number line, remember, the square root of 36 is really equal to 6, and the square root of 49 is equal to 7. So the square root of 42 is going to be somewhere around here. And do you see how these numbers fall in line? We got 36, 42, and 49. Because this represents an estimated value of where the square root of 42 is. When we try to find, when we estimate values with square roots, we take a decimal estimate and then we can place that on the number line and think about which perfect squares it falls between. So this was section 1.5, square roots and real numbers. Go ahead, try your homework. Thanks for watching.